Hello students, and we're ready for section 4 of chapter 11, where we are going to learn all things quadrilaterals. I want you to understand the definition of a quadrilateral, what all that will mean if you know that it's a four-sided shape, and then we're also on the next page going to talk about special quadrilaterals. So first we'll start with the definition. What makes a shape a quadrilateral? I'm sure you already know it means that it has four sides. So a closed figure with four sides, which also means it'll have four angles. Now the segments of a quadrilateral intersect only at their endpoints. So to the right we have quadrilateral A, B, C, D. We usually name them in alphabetical order. So I'm highlighting quadrilateral A, B, C, D. The sides of our quadrilateral are segments AB, segment BC, segment CD, segment DA. If we talk about the vertices, we're talking about each point at the corners of the angles, and then of course the angles are angle A, B, C, and D. Now if I took my pen and I divided my quadrilateral, I now have two triangles, and hopefully you remember from chapter 10 that each of the triangles is 180 degrees. All the angles of this triangle add up to be 180. Well, guess what? All the angles of the other triangle, these angles, all add up to equal 180 also. So when you put the two 180s together, 180 times 2, because I have two triangles here, you end up with 360 degrees. So a quadrilateral can be separated into two triangles. We know that the sum of the measure of the angles of a triangle is 180 degrees. So the sum of the measure of the angles of a quadrilateral is two 180s, therefore 360 degrees. So what I want you to really remember is that if I tell you you have a quadrilateral, then you know the total of your angles is 360 degrees. And using that information, you're able to solve problems like our first example. Go back to what we know about all the angles of a quadrilateral, the 4x that I don't know exactly what it is, plus the 3x, plus I have 130 degrees and I have 90 degrees. All four angles must add up to equal 360. We did something similar to this in chapter 10 about our triangle. So now I have 7x plus 220 equals 360, and I'm solving this equation algebraically. So I'll subtract 220 from both sides to isolate my x. So 7x equals 140, and now to get x completely alone I need to divide by 7, and you find out that x is 20. So it said to find the value of x and then find each missing angle. So now that I know x is 20, I'll take my 20 and I'll go back and say 4 times 20 is 80. So angle B is 80. 3 times 20 is 60. And those were the missing angles because I already knew 130 and I already knew 90. Alright, I am going to let you do these next three on your own. Don't forget to go back and find the missing angle, and each of these quadrilaterals have a sum of 360 degrees. I'll set the first one up for you. You'll add your 55, your 105, your 140 plus your x should total 360. So that's a total of 300 plus x equals 360, and I think you can get it from there. So for this one you only have to find the x. Here after you find x you'll multiply times 3, and number 3 you'll just find x. Alright, so pause here and try those on your own. Now we're ready for the back, where we are going to classify our quadrilaterals. So there's more than one type of quadrilateral, and they have those listed here. There's a trapezoid, a parallelogram, a rectangle, a rhombus, and a square. So let's read our definition so we can understand the difference in each one. For a trapezoid, there's exactly one pair of parallel sides. So to give you a rough sketch of a trapezoid, you're going to have one pair of parallel sides, but the other two sides need to obviously not be parallel. So that's what a trapezoid would look like. For a parallelogram, both pairs of opposite sides are parallel. And by the way, they're also congruent. So a parallelogram usually is a squished rectangle where you've got both pairs of opposite sides parallel. We'll do the arrows, which means parallel. And they're also equal. Don't forget that. That's important. A rectangle is a parallelogram that has 4 right angles. So it'll look very similar to that picture, usually longer and skinnier. And you also know the 4 right angles on top of knowing that they're parallel. So that makes a rectangle. Make sure you know that goes with rectangle. A rhombus looks a lot like a parallelogram, except for this one you know that the 4 sides are congruent. So a rhombus, let's make it blue. It's also usually squished, but all the sides are equal. And then a square is a rhombus, and it's a rectangle. It's a rhombus because all sides are equal, and it's a rectangle because all the angles are right angles. So if I could borrow, let's see, this problem says to classify this quadrilateral and give the name that best describes it. Well, since all the sides are equal, I know that it has to be called a rhombus because of all the sides being equal. That's the only one besides a square, and I don't know right angles. Remember, you never go by looks, and these don't even look like right angles, but they have to tell us that they're right angles before I can say it's a square. So I'm going to borrow some space here with this example, and I want to make you a little chart. I'm hoping this chart can clear things up. So our main category is quadrilaterals. That's your main heading. Under quadrilaterals, there's this one little lone quadrilateral called a trapezoid. Then over to the left, there's this bigger category called a parallelogram. Within parallelograms, you might have a rhombus where all sides are equal, or you might have a rectangle where all angles are equal. Or you might have a funny little combination of the two where all sides are equal and all angles are equal, called a square. So all of these are quadrilaterals. A trapezoid is in a classification all of its own. A parallelogram has different types of parallelograms within that classification. So remember, if I asked you, is a rectangle a square? You'd say no, because you don't know if the sides are equal. But if I ask you, is a square a rectangle? Then you should say yes. Is a rhombus a parallelogram? Yes. Is a parallelogram a rhombus? Well, I don't know. Are all the sides equal? So this is a nice little chart to help you classify your quadrilaterals. So as we try these next few examples, see if that chart will help you. So for the first one, I don't have all sides equal. I only have opposite sides equal. Well, for opposite sides equal, go back up to this chart. If we know opposite sides parallel, I don't know about parallel, but I know they're congruent. So the best I can say for the first one is that it's a parallelogram. I don't know why I want to write in the picture. You can write beside the picture. Here we have 4 right angles, opposite sides congruent. This is definitely a rectangle. Number 3, do I know parallel? They don't look parallel. If they mean for them to be parallel, they'll be like number 6. There will be some arrows. So I don't know parallel. I don't know right angles. I don't even know equal angles. the best I can say about this picture is that it's a quadrilateral. I do not know anything else except that it has 1, 2, 3, 4 sides. All right, I'm going to leave the other 3 for you to see if you can classify, and we'll talk about those when you come to class tomorrow. But before I go, I have to ask you, why is a circle better than a square? Does anybody know why a circle is better than a square? Well, a circle is more well-rounded, which makes it better. Have a great day.